Hello all, in the last tutorial we were discussing about 2 to 4 decoder. In this tutorial we will be explaining further more about it, that is what if enable is made high or enable is connected to VCC. So you can see Y3 is nothing but AB, Y2 will be equals to AB bar, Y1 will be equals to A bar B and Y0 will be equals to A bar dot B bar. That is if enable is acting as 1, that is it is connected to VCC. So if you remember the terms of min terms, like if I have A B 0 0, 0 0 is called as M0, 0 1 is M1, 1 0 is M2 and 1 1 is M3. This is the representation of min terms. So you can see the output of 2 to 4 decoder is nothing but M0, M1, M2, M3. That is if enable is made to bit 1 or it is sorted to VCC. So let us discuss about implementation of full adder using decoder. That is the example of 3 to 8 decoder. Why 3 to 8? Because full adder has 3 inputs A, B and C. So I'll bring 3 inputs and the output of decoder will be 8. But as full adder has 3 inputs but the output of decoder is 8, we require how much outputs? 2 outputs. So now in order to design for 2 outputs, what I will be doing is I'll be representing in terms of min term. So if I see the output for sum, it is nothing but summation m for 1, for 2, for and for 7. For this 1, 2, 4 and 7, I need to use an OR gate so that I will be having the output as for sum. That is what I will do is I will connect with m1, say this is M2, M4 and M7 with an OR gate. So this output will be generated as sum. Similarly for carry 3, 5, 6, 7. So 3 connected to a OR gate, this will be my generating as carry. So as you can see, 3 inputs and 2 outputs, that is required output sum and carry for full adder. So this is how the decoder 3 to 8 decoder is being used to implement of full adder. Hope this tutorial is clear to you all. Thank you.